Okay, so looking at this question here, we're dealing with a trigonometric equation. Now, when we see this type of equation, we're solving for x and we want it in terms of degrees. But one thing that you'll notice about this trig equation is that it's not our typical exam type equation where we just have, for example, cosine 2x is equal to root 3 over 2. This one is more straightforward because we're only dealing with one trig ratio here. But here we have 4 cosine squared x minus 3 sine x minus 3 is equal to 0. My biggest concern here is that we have two trig ratios. We have cosine squared x and sine x here. So the first thing that we should think about is how can we get rid of one of these, or not really get rid of it, but change it. And one identity that we can use in the log tables is cosine squared x plus sine squared x is equal to 1, right? Because now we can say that cosine squared x is equal to 1 minus sine squared x. Now we can take what we got from here, so the 1 minus sine squared x, and replace it in for cosine squared x in the equation here. So if we do that, we'll end up with 4 by 1 minus sine squared x minus 3 sine x minus 3 is equal to 0. So now we've gotten rid of the cosines and we have an equation all in terms of sine. So I'm going to go ahead and multiply out this bracket here. So 4 minus 4 sine squared x minus 3 sine x minus 3 is equal to 0. So that's minus 4 sine squared x minus 3 sine x plus 1 is equal to 0. Now, so we've gotten rid of the cosine, but this equation still looks fairly difficult. But one thing that you can realize is this is actually just in the form of a quadratic, namely because we have a sine squared x here, a sine x here, and a constant at the end. So I'm going to multiply all across by a negative, by a minus, because that gets rid of my minus 4 here. So that will give us 4 sine squared x plus 3 sine x minus 1 is equal to 0. So at this point, what we should do is we should try and change this and make it look more like a quadratic. So we can let some other variable, we're just going to say maybe y is equal to sine x. Now we can replace y with sine x in this equation. So 4y squared plus 3y minus 1 is equal to 0, right? So now it's just a simple case of solving this quadratic. And to solve this quadratic, we can use either minus b formula or we can factorize. So I'm going to use minus b here. So minus 3 plus or minus the square root of b squared minus 4ac all over 2a, right? Then we'll take our calculator and input all these values. We get one answer is 1 over 4 and another answer is minus 1, right? But we're not done here because we're saying y is equal to these values, but we're not solving for y in this question. We're actually solving for x, where x is between 0 and 360. So that means we need to let sine x is equal to 1 over 4 and sine x is equal to minus 1. So here, what we want to do is we're going back to the original type of trig equations that we have, where we just have one trig ratio and it's equal to some value. So here we have x is equal to sine inverse of 1 over 4 and x is equal to sine inverse of minus 1. So inverse sine of 1 over 4, that gives us 14.48 degrees. And then we have inverse sine of minus 1, which gives us, sorry, we shouldn't include the negative sign, inverse 1, which equals 90 degrees, right? But are we done here? No, because remember, the range of values that we can actually potentially get for x is between 0 and 360. So we need to go and draw out our cast circle and figure out where the other angles lie. So firstly, we have sine x is equal to 4, so positive 4. So where is sine positive based off of this? So sine is positive in this quadrant and this quadrant here. So if I draw it out, I have this quadrant and this quadrant. So I already have 14.48. Now, when we're in the second quadrant, what do? We subtract 180 from the angle that we already have. So 180 minus 14.48, that equals 165.52. And then finally, the last one here, sine x is equal to minus 1. So where is sine negative based off of this unit circle or cast circle? So we have CASD. So sine is negative in tan and cosine. So what do we do when we have an angle in this quadrant and this quadrant? Well, if we have an angle in this quadrant, we add 180 to it. So we have 270. And then if we have an angle in this quadrant, we subtract 180 from it, 360. So again, we still get 270. So these are our answers, 270, 14.48, and 165.52. Now, just to recap about this idea of a unit circle, in a nutshell, depending on what quadrant we're in, we treat our so-called reference angle accordingly. So if it's in the first quadrant, so all angles are positive, we leave the angle alone. So theta is just theta, we don't touch it. Now, in the second one, we subtract 180 from whatever angle that we get here, right? And then in the third quadrant, we add 180, so 180 plus theta. And finally, in the last quadrant, we subtract 360 from it, 360 from the angle at hand.